Alright, welcome to video 4.3, looking at how atoms differ. Main objectives are to define what isotopes are and how they differ within an element. And then lastly, calculate the number of electrons, protons, and neutrons in an atom given atomic mass, mass number, atomic number, and or elemental name. For this particular section here, what really comes into play is your knowledge of what the charges are of protons, neutrons, and electrons, and what their masses are as well. So make sure you know that information we learned in the prior video. Alright, so getting started here. When you're done with this video, you should really be able to answer these questions. What makes an atom of one element differ from another? So what makes carbon different from iron, I guess? That's one way of asking it. The other question is, how do atoms of the same element differ? So if you have two atoms from carbon, how might they differ? Okay, that's really what we're looking for in this particular video. So let's start with the first question. What makes elements different from each other? Start off by doing the box portion of your notes here, where it says atomic number. The atomic number really means this. The atomic number is the number of protons. Okay, so when I say atomic number 6, we mean that thing has 6 protons. Okay, that's what that means. And it turns out, for the most part in this chapter, we'll start off by saying this, that atoms are neutral. Okay, the reason atoms are neutral is because the proton number is equal to the electron number. So the number of protons is equal to the number of electrons. So I never want you to say that atomic number is the number of electrons, but they are if you have an electrically neutral substance. Okay, so the atomic number is the number of protons. When I ask you that, you should say those two things together. Alright, so let's look at the paragraph quick here. So basically, if the overall charge of an atom is neutral, write that down, if it's neutral, the number of protons then is equal to the number of electrons. That's why it's neutral. Once you know, now we're in the paragraph where you need to fill in a little more here. Once you know the atomic number then of an element, you can use the periodic table to to find the identity of that element. I guess I wanted identity there. Okay, so let's go to the periodic table for a second. So earlier I had used the example of the atomic number is 6. That means it has 6 protons. Well, let's go to the periodic table and find atomic number 6. Okay, so here's our periodic table. The atomic number on our periodic table is listed in the upper left-hand corner. That's the atomic number. So let's find 6. And the periodic table goes by rows, and they're all numerically in order. So it's 1, 2, 3, 4, 5, 6. That is carbon. So once you know the identity of carbon, the atomic number is 6, you can find the identity then, which is carbon. Okay, and that goes both directions. If I say nitrogen, what's the atomic number? Its atomic number is 7, and therefore it has 7 protons in that atom. Okay, so I think we have a little practice here coming up in our notes here. So let's go to the let's go to that practice. Okay, so I'll do the first ones with you, and then you can do the last two on your own. So we just did this one. The atomic number is 6. We looked it up. That was carbon. So you'd write carbon here. And then if the atomic number is 6, that is the number of protons. And for now, we're saying the atoms are neutral, which means protons and electrons are equal to each other. So we have 6 electrons as well. Okay, let's try sodium. So let's look up sodium on our periodic table. Sodium is over here. It's Na for a chemical formula, and the atomic number is 11. So the atomic number is 11, and that's equal to the number of protons. Those are always the same. And because the atom is neutral, it also has 11 electrons. So you pause now and try the last 2 rows and see how you can do. Okay, so this one says 26 protons, so because it's neutral, we'll say it's got 26 electrons. And then the proton number is the atomic number. So protons is the atomic number. Now let's find 26 on the periodic table. And 26 on the periodic table, lo and behold, no surprise here, I picked iron. Okay, so 26 is iron. Okay, if you got that one wrong, double check the next one before you see the answer. Okay, this one has 17 electrons. Assuming the atom is neutral, it's going to have 17 protons as well. 17 positive charges to balance off the 17 electrons. The number of protons is the same as the atomic number. And look up 17. 17 is chlorine. Okay, so hopefully you see the relationship here now between atomic number and protons, and now we can use that to the atomic number to identify who the element is, or vice versa, use the name to find the atomic number and so forth. Okay, so back to the question. What makes one atom of an element different from another? It's all about the number of protons. Carbon has 6, iron has 26, uranium has 92, neon has 10, and so forth. They all have different numbers of protons. The next question we're going to answer is, how do atoms of the same element differ? So if you have 2 atoms of carbon, how might they differ? Well, it comes down to the definition of isotopes. Isotopes are atoms of the same element that have different numbers of neutrons. Okay? And because they have different numbers of neutrons, they have different masses. So write that down and listen for a second. Isotopes are atoms of the same element with different numbers of neutrons. And the reason they have different masses as well is because, remember, protons and neutrons are the particles in the atom that have most of the mass. And they contribute to the mass. So therefore, if you have different numbers of neutrons, that'll make the masses different as well. Okay, so isotopes have different numbers of neutrons, that's the key there, and as a result they'll have different masses. And as a final note here, in terms of their chemical properties, isotopes of the same element will still have the same properties. So although some things might weigh more than other things, they still have the same chemical properties and will behave the same. Alright, so to identify how 2 isotopes might be of the same element, one thing we like to use is a thing called mass number. So write this down for mass number. Mass number is always a whole number. One thing. And it's going to be equal to the number of protons plus the number of neutrons. And that's why it's a whole number. It's just how many protons are there? Maybe 6. How many neutrons are there? Maybe 6. Add them together, the mass number is 12. So it's always a whole number. And this mass number helps us identify isotopes of a particular atom. So an example I have here is copper. Copper has 2 isotopes. One's called copper 63. That's the mass number right there. One's called copper 65. Now because it's copper, let's look up what copper is for a second. Copper is right here on the periodic table, and it has 29 for atomic number. So the atomic number is the number of protons. Okay, so copper has 29 protons. Both of these have 29 protons. Because it's copper, it has 29 protons. But if the mass is 63 for one of them, and the mass number is 65 for the other one, that's because it has different numbers of neutrons. So it takes 34 neutrons to get to 63 there. So 29 plus 34 protons plus neutrons adds up to 63. For the other version, 63 for a mass number, 29 protons plus 36, 2 more neutrons this time, will get you to 65. So mass number helps us identify which isotope we're talking about, whether it's this one or that one. And then you can kind of reason out how many neutrons there must be, because it has to add up to 63 and 65. Or vice versa, I could provide you this information here and make you come up with the mass number there as well. Okay? There's a question in your notes there explaining why isotopes of the same element have different masses. You should be able to answer that question now as you do that one. Okay, now let's look at isotope notation. I'm going to add a 12 and a 6 here to this one. There's 2 different types of isotope notation. One looks like this, the other looks like that. And essentially here, the element here, that's the identity. And if you know what the element is, carbon, from that you can find the atomic number, right? You look at the periodic table, you can find the atomic number. And then from that, the atomic number, don't forget, is the number of protons. And from that, if it's electrically neutral, you can figure out how many electrons there are as well. In this type of notation, this right here is called the mass number. And don't forget that mass number is number of protons plus neutrons. So this is the element, that's the mass number. And then from each of those things, you can find this. And from the element carbon, you can look up the atomic number, and it leads to the rest of that information. In this other version of isotope notation, I'm going to add one more thing here. It's not in your notes yet, but let's add it right now. Let's put a 4 minus, I guess, right here. Okay. So this top number here is still the mass number. So from that, we basically know protons plus neutrons. This bottom number here is actually the atomic number. And I'm just going to draw an arrow way up here like so. That's the atomic number, okay? And from the atomic number, you can find protons and electrons should you need to, okay? And this up here is kind of a new thing. I'm going to add in our notes here. This is the charge. Something we'll do a little practice with later in this chapter is charge. Charge of ions. Whenever an atom becomes not neutral anymore, now we call it an ion. So if you ever see a number up here that has like a plus or a minus like that, in this case 4 minus, that's the charge of an ion. And the charge here has to be the protons plus the electrons. Okay, so if the charge is a 4 minus for a charge, that must mean there's 4 more electrons than protons. So let's just do this quick. So if the charge is 4 minus, here's the atomic number, which is the number of protons. So there's 4 positive protons, and this is 4 minus. What must electrons be? It's a negative number here. Okay, it's some number and it's a negative. So we have 4 plus something will get us to a 4 minus. And it turns out we need 8 electrons. 8 electrons at negative charge plus 4 protons ends up being an overall negative charge. So that part's kind of complicated. We'll practice that a little more in class. Okay, but this is isotope notation. And just make sure you know that this is mass number here, and so is this one. And then on this type of notation, this is the atomic number, which is the number of protons. So to kind of wrap it up here, what do you know? Essentially, if you know what an element is, okay, so I'm going to go to the periodic table. If we're talking about cesium, which is, that's too low. Let's talk about magnesium right there. If you know it's magnesium, know it's the element, you know the atomic number. Okay, so if you know the element name, you know the atomic number because you can look it up on the periodic table. And if you know the atomic number, that should be the number of protons. And if it's electrically neutral, that's also the number of electrons. So just from an element name, you know each of these things. And in fact, if you know one of those 4 things, you can find out the other ones as well. Okay? All right, up last, we have some practice with isotope notation. I'll do the first 2 rows with you, and I want you to practice doing both types of notation here. So let's do this type of notation, put a star by that. Let's practice that one here, and let's practice this type of notation here and here. So I'll do the first 2 rows, and I'd like you to do the last 2 rows on your own for practice and see how you did. So in the first row, the mass number is 8, and don't forget that mass number is protons plus neutrons, and we have 8 protons. So from that, the only thing we don't know is neutrons. So if you have 8 protons, how many neutrons then gets you to 16? The answer is 8. And on this particular page here, one more thing I want to mention, everything is neutral. So that means protons is equal to electrons. So we also have 8 electrons. The atomic number, don't forget, is the same thing as the protons. So our atomic number is 8. And let's look up what this is then. If the atomic number is 8, 8 is oxygen. Okay? So this is oxygen. And then we're going to put the mass number in a hyphen at the end there. Oxygen 16, because the mass number is what we put on the end here. Okay? For other practice problem, let's see, we got 3 electrons. I told you everything's neutral here, so they're equal on this worksheet. So 3. The mass number, don't forget, it will be protons plus neutrons, which we do have. So that's going to be 7.
Mr. Kennedy says hey.
Mr. Kennedy says hey. Oh boy, it's lunchtime. I should probably wrap this up. Don't forget the atomic number is the number of protons, so that's also 3. Go to your periodic table. Periodic table, atomic number 3 here is lithium. So we're going to use the symbol this time, Li for lithium. The mass number goes up here, so 7. The atomic number goes down here, so 3. And we're not going to do charge stuff right now. And plus it's neutral, so it's going to be neutral there. So please try the next 3 rows on yourself here, and then unpause this when you're done and see how you did it, and then come ready tomorrow to practice this a little more. Scratch that. The video's getting long enough. I still want you to practice these, so come with these last 3 rows done, and we'll check your answers tomorrow, and we'll practice more along with this isotope notation. Thank you.